So I'll just dive in. We have some introductions that I'll be giving. Then Rochelle and Arnav are going to give their presentation, which you see. And the rest of the time is just for questions and discussion around anything that comes up today. So without further ado, we have here with us today Rochelle Yarabelli, who's a sophomore from West Hartford, Connecticut, majoring in biomedical engineering. Rochelle enjoys building and creating and has a strong motivation to find solutions that can help the environment, something that we believe in as well. He is involved in computational biology research where he studies the immune system, and outside the classroom, he's a bassist with the Duke Jazz Ensemble. We have Arnav Singh as well with us. Arnav is a Durham native and a sophomore in biomedical engineering. He loves to create devices that can direct and immediately impact the community, one of which is a proposed model that we're hearing about today. On campus, Arnav is involved in organizations such as QuadX, the Duke Vertices Academic Journal, and holds the position of president of the Wanamaker Quad and senior editor of the publication. Rochelle and Arnav are both looking forward to speaking with you all today about their ideas. So thank you, everyone, and I will turn it over.
Hi, everybody, and my name is Arnav, and along with Rochelle, we are sophomores in the Department of Biomedical Engineering, and we have before you a planned proposal for a small-scale recycling center here at Duke University campus. So before we dive in, here's a brief roadmap for our presentation. First, we're going to start with a brief summary of what we have in mind for this initiative, and then we're going to go and take a closer look at the status quo, the challenges with current recycling infrastructure at both a global and a smaller campus level. Then we're going to discuss how Duke Precious Plastics specifically can address these challenges head on and have an impact on mitigating plastic pollution on campus in 5 key ways we have outlined. We'll also dive into the technical aspects of this initiative, such as the machine, the design of them, how much they're going to cost, where they're going to be located on campus. Also, more broadly, the general journey that plastic waste is going to take from campus trash cans into our plastic products. I'm also going to discuss the feasibility and implementability of such an endeavor, and then we're going to open it up and discuss our next steps and open up for questions and comments and foster an open discussion. However, before we do move on, we have a brief disclaimer. Our idea is still in its infancy, and there is a certain level of nuance that we're yet to consider, however, hope to do in the future as we move forward. Our goal for this presentation is to share with you ideas that Duke undergrads currently have to address plastic pollution and show that there is a room for action that we are willing to take. We hope that you can provide us with the constructive criticism, guidance, and possible even funding and mentorship to make our initiative a reality. That being said, here's a summary of our idea. In one sentence, our main goal for this initiative is to turn single-use, short-life plastic waste that's elsewise thrown out rapidly and in large quantities on campus into long-use plastic products that will last for much longer before eventually ending up in landfills. What we're planning to do is create a plastic recycling workspace directly at Duke University campus for small-scale recycling purposes, where campus waste will be turned into plastic products. Broadly speaking, the goal of our proposed organization are twofold. First, we want to mitigate the actual contribution that Duke as a university has to plastic pollution. We also want to serve as an educational resource for the Duke and local Durham community to learn how plastic can be recycled at a small scale. So the workplace itself will consist of a series of machines that will beginningly shred, then melt and extrude, eventually mold into specific shapes that we want our plastic to be, and compress it into the final desired product. We envision this process to be a cross-disciplinary process where the sale of these finished products can create a stream of revenue that can actually support workplace operations, which otherwise we know is a big barrier to keeping these things running. Moreover, we see this workplace as a driver for both educational and research opportunities. After all, we are a research university, to learn both more about plastic recycling and study ways to further advance the decreasing of plastic pollution and increase sustainability here on our campus.
So now we're going to take a closer look at the problem and some of the challenges with recycling in the status quo. So on average, we as humans produce about 400 million tons of plastic every year, of which only 9% of the plastic is recycled. This means that the vast majority of plastic waste ends up going into landfills and the oceans, and some of it is also incinerated as well. So clearly, the amount of plastic waste that we produce, a lot of it is not being recycled and instead goes into our environment and causes tremendous amounts of plastic pollution. From the year 1980 to 2018, the amount of plastic waste has increased almost 7 times, yet the plastic recycling rate has remained at a constant 9–10%. By 2050, it is expected that we as humans will triple our plastic production rate than what it is at the moment. However, the recycling rate will still be expected to be around the same. What ends up happening now is that we're going to have tremendous more amounts of plastic pollution on Earth, and this will continuously mean that more and more plastic will end up going into our environment, into places like the landfills and the oceans. And I'm sure, as probably you all are aware, there are tremendous downstream consequences with an increased amount of plastic pollution. So why is our recycling rate so low? Well, recycling facilities have to manage all sorts of waste, not just plastic. They have to deal with paper waste, glass, aluminum, all other types of materials that are also recycled as well. What this means is that you have a tremendous, so many types of waste that come in, which makes it very difficult and labor intensive to sort this waste. Typically, you have workers that stand around a line of waste coming in, and they have to select products that they think, or items that they think can be recyclable. And oftentimes items like plastic sort of miss this process simply because A, they're not recyclable, and B, because they aren't clean or they aren't of good quality recycle. And as a result, a lot of waste just ends up going into the landfills. We also see that even if we are able to recycled plastic is less durable and more expensive. So there's less of an incentive for companies to use recycled plastic when they create their product, which means that there's overall a smaller market for recycled plastic. We also see that countries in the West, like the United States, tend to export plastic to other countries like China and Thailand and have them deal with our plastic waste. However, in 2017, China banned plastic waste exports from the United States. This means that the US has just so much plastic waste sitting around domestically, and a lot of places in the United States don't have the proper recycling infrastructure, and as a result, a lot of this waste ends up going into the landfill. So what does this mean? What are the consequences at the individual level? As you are all probably aware, there's so much campaigning around college campuses and places in the workplace about how important it is to recycle, how the 3 R's. And there's a tremendous amount of push towards recycling that the plastic industry and the recycling industry has created. And what this has done is that it has created a false perception that there is actually a solution for people to sort of recycle their plastic. However, in the reality of the situation is that the plastic actually doesn't end up being recycled. Instead, it goes to the landfill. Having this false perception is generally a bad thing, because what this means is that people will think that there is a solution to the problem, which is recycling, when in reality, this really isn't the case. There's this term called wish cycling, where people have the intention to recycle plastics, but they don't know what it means to recycle. So they'll just throw items in the recycling bin with the hope that it will be recycled. But instead, that just puts a greater burden on the system. It just makes it harder to sort plastic and so forth. So now we're going to talk about the impact and why might creating a plastic recycling workspace on campus address some of these issues. And we have a 5 impact framework for this. Number 1 is waste diversion. Number 2 is waste reduction, environmental equity, research and innovation, and community influence. A bit more on each of these. What we mean by waste diversion is that we want to divert waste that would otherwise end up in landfills and oceans into a recycling center where we can process the plastic and create plastic products out of this that would eventually prevent the delay of those products into the environment. What this does is that it will limit plastic pollution and limit carbon emissions, as a lot of plastic does end up being incinerated. What this ends up doing, broadly our goals of this would be to turn single-use plastic items that have a lifespan of about a week, like a plastic fork, which is people just use for about 30 minutes and throw away, to items that can last a long period of time, for example, like plastic furniture, which people will use for many, many years. Next is this idea of waste reduction. And this is where sort of the educational outreach component of this organization would play a major role in. We want to provide resources to educate individuals on plastic consumption and recycling. And so this would be to educate people on like, you need to clean your plastic, you need to wash your plastic, you need to remove all the different labelings in order for it to even be recycled. But even before recycling, emphasize like the first principles of what it means to like reduce your consumption, reuse plastic as often as you can. And what makes this approach unique is that it gives a very hands-on education. We see that when like people have a tangible experience, when like recycling things or like working with materials in general, it can inspire long-term like behavioral changes, versus broadly what we've seen is just, people like giving informational like sessions on what it means to recycle. Instead, we can provide a very like hands-on approach when we can show people how we can actually recycle plastic. And what this means is that if we can inspire this long-term behavioral change, we can reduce the amount of waste created. Thirdly is this idea of like environmental equity, and having community-based recycling can promote this equity. As I mentioned before, the US and other countries in the West tend to export plastic waste to other countries. And what this does is it puts a burden on the people who aren't even producing this amount of plastic waste in the first place. In order to promote this environmental justice, the people who are producing the waste, as like Americans, we must manage the waste domestically, and having this like community-based recycling promotes this, as opposed to exporting this waste to other countries and having other people have to take on this burden. Fourth is research and innovation. Essentially, having a workspace gives a tremendous opportunity for students to like learn more about plastic recycling, but also innovate in the space as well, like improve the recycling machinery, like make the machinery like a smaller footprint, more modular, more transportable, decrease that recycling time, but also to create new plastic products and even alternatives for plastic, like things like, biodegradable utensils. It's research and innovate in this space as well. Finally, is this idea of community influence. Like, should we be able to like create a successful space on our campus, it can inspire other university campuses, local neighborhoods, and communities in the developing world to do the same. And so this means that if we have more and more of this initiative to take on plastic pollution, having this inspiring would obviously decrease the amount of plastic pollution we see. Now that we've sort of laid out what roughly our idea is and some of the problems and the impacts we hope to have, we'll talk about the feasibility and the technicality, like how exactly are we going to turn this plastic waste into plastic products. And so fortunately for us, there's this organization called the Precious Plastic Organization, which is this open source organization specifically created to tackle plastic pollution through recycling spaces. And so what they've done is they've created a bunch of video tutorials. They've created a ton of design manuals in terms of how to develop machines to help recycle plastic at a very small community-based scale. And their whole mission is that plastic inherently is a precious material, and therefore like it shouldn't be wasted, but instead it should be used and have many different uses. And so this precious plastic has inspired several chapters of this to be started around the world, and some of which are plastic recycling facilities at universities. Some of the more successful ones is the one in Monash University in Australia. And what they've done is they've taken the original precious plastic machines, which are made to be housed in a 40-meter by 10-meter area into a 5-meter by 5-meter area. So they've considerably decreased the footprint of plastic recycling units into a very small space, as shown in this picture here. Another university is Ohio State University, and they've also have had similar successes in terms of creating these plastic recycling workspaces on their campus. So since other universities have been able to create these plastic recycling workspaces, this is definitely something possible that can happen at Duke, given the right support and the right resources. Broadly, we see that there are two types of recycling machinery. We call them low fidelity machinery and high fidelity machinery. What we mean by low fidelity machinery is that it's very simple machinery. It can be reproduced at no cost and can be developed right away. With the only downside is that there's limited amount of products and there's more manual labor, but these machines can be produced at no cost. The high fidelity machinery refers to the machines that you've seen in the last two slides. And this tends to be more sophisticated. It takes more time to develop, costs more money, but you can create a diverse set of products. It's more automated, and there's a greater scope for innovation. Some examples of like low fidelity machinery products is making plastic string from plastic water bottles. And so with this clever mechanism, you can create different plastic strings out of this plastic water bottle. And these strings have, tremendous amount of use, especially in like engineering labs. The string can also be wound into rope, which again, these are plastic products that can be used over and over again, as opposed to a plastic water bottle, which would likely end up in the landfill. Other examples are like tote bags. So if you just take a plastic shopping bags and then iron them onto like fabric and then stitch it together, you can create plastic tote bags, which are much durable, much longer lasting bags that people can use for like grocery shopping, for instance. And these are examples of high fidelity machinery products. And of course, there's a lot more diversity in terms of products here. You can create plastic bowls, plastic flower plants, furniture. People have gone really creative and have created like jackets and skateboards and plastic art, and like guitar bodies. And so there's a lot more scope and a lot more product diversity with this high fidelity machinery. Some of the steps specifically for this high fidelity machinery involve collection, sorting, cleaning, shredding, melting, and molting. In terms of collection, we envisioned at Duke that we would collect number 2, number 5, and number 7 plastic. Specifically with number 7, it's like broadly categorized as miscellaneous, but for Duke purposes, we'd specifically focus on 3D printer waste. At Duke, in all of the maker spaces, so many people are constantly using the 3D printers, but those also generate so much plastic waste. So we would hope is to be able to recycle 3D printer plastic waste. We'd also focus on collecting single-use plastic items. And in terms of the collection process, we'd probably place bins outside of the workspace. And so with instructing people to drop specifically like the types of plastic that we want. And this was where like the education component comes into play. There's also opportunities to partner with like Duke Sustainability. And of course, you see like recycling bins across campus. So coordinate with them. Also Duke Dining, maker spaces, local businesses, large campus events to also collect waste. In terms of sorting, the plastic must be sorted in terms of the type of plastic. It also could be sorted into the color of plastic if you wanted to create like plastic products of a specific color. This also goes hand in hand with the cleaning stage, where plastic waste must be cleaned to prevent any impurities. This could include food and leftover residue, or in like water bottles, for instance, like the plastic wrapping and like bottle caps. There are a few ways you can clean the plastic. One is obviously to hand wash it. At Ohio State, they developed a clever mechanism where they shred the plastic before it's clean, and then they put it to like a washing machine system that removes all the food and leftover residue. And then you obviously shred the plastic. This is an example of the Monash University plastic shredder. And the whole point of shredding plastic is so that it's easier to melt and easier to reshape. Then you have the different stages of melting and molding. There are 3 components to this. The first is an injector, where essentially you're melting plastic pellets into a heated barrel, and that's injected into this mold. So as you can see in this image, what he does is he pours the plastic pellets into the injector and then pushes down on the lever. And what this does is that the barrel is heated, and so the plastic comes out of the injector like toothpaste coming out of a tube. And so this can be injected into a mold, and then once it hardens and dry, you have a plastic product. The next thing is a compressor. What this does is you can squeeze 2 molds together inside an oven. There's also a sheet press, which is to make like large flat sheets of plastic. So you can make tables or any flat surfaces with a sheet press. And finally, there's an extruder. This is probably where we see the use of like recreating potentially 3D plastic filament. What this is that you have plastic pellets go into like a heated screw, and as the screw twists, the plastic extrudes out into a filament that can then be wrapped around and potentially be used as like 3D filament, but there's other use cases as well. In terms of cost, these costs are taken from the Precious Plastic Design Handbook, and rounds to about $13,700. In terms of like acquiring all this machinery, there are like a few things. First, you can like build all of this. The instructions and the guidelines and the safety has all been sort of open source and is online, and it's possible. It just requires a lot of labor and a lot of people working on this together, but it's certainly possible. The other thing is to possibly purchase these machines directly and just get started with recycling right away. Or it could be a combination of both, where you might build some components and purchase other components as well. Yeah.
Sorry, folks, for the background noise. Ironically, the recycling truck is right outside my house right now. But so you've heard all of this. What exactly are the next steps? So first and foremost, we would like to establish a formal organization, potentially as a wing of the Plastic Working Group, from which we could recruit other undergraduate and graduate members who share the same passion as we do and contribute to our mission. Second, since we know we're just students ourselves, there's a lot we don't know and don't yet have experience with. And as such, we'd like to find a faculty mentor or advisor who could help guide us through this process. We'd also like to find a designated workspace for ourselves, or designated times and storages and on-campus makerspaces we could mesh out the engineering of the machines that were proposed earlier. From there, we could grow as an organization and branch out into several sub-teams responsible for heading other tasks. Like there can be a team for engineering, outreach, and finance specifically to fund parts of our mission. On the note of finance, this is a project that would require an amount of funding, as we just talked about. What we hope is that you could direct us to resources, whether that be university resources or external grants, to provide the funding for our initiative. Finally, we see this initiative as bigger than just a small-scale recycling center. We aim to partner with on-campus organizations, not just to spread awareness, but to foster further advances in our mission. For example, some that I've outlined for you today, there's the Earthy Art Company, which is a college-run sustainable art company that makes pieces entirely out of recycled plastic. Furthermore, there's an engineering group called Duke Enabled that builds next-generation prosthetics at a low cost, which could be made entirely out of recycled 3D printer material. We'd also partner up with Freshman Engineering 101 classes to launch a project focused specifically on environmental engineering, serving both the purpose of incentivizing students to take part in our mission, but also getting them interested in environmental engineering at an early point in their career. So that's our presentation for you guys today. We hope to open this into an open discussion where you can take questions and comments and foster an open discussion.
Thank you all so much. I will help to field questions